taken the topic isomerism. So when it comes to isomerism, first it is important to understand what is meant by isomerism. Isomerism is the phenomenon in which more than one compound have the same molecular formula. Their molecular formula is same, but they have different structure. The structural formula is different for them. Now in this definition, one word has come, molecular formula. So let us first understand what is the meaning of molecular formula. When I say molecular formula is a formula which gives us what all atoms are present in a molecule and how many. For each atom, how many atoms are present for that specific atom. For example, when I write the molecular formula C6, suppose I write C6H14. So this tells me that in this specific compound you have 6 carbon atoms and you have 14 hydrogen atoms. Similarly, if I write for glucose, this is the molecular formula for glucose. This tells me that in this molecule there are 6 carbon atoms, there are 12 hydrogen atoms and there are 6 oxygen atoms. So this is what is molecular formula. So the compounds which have same molecular formula, their molecular formula will be same. What does it mean? Same type of atoms and the number of atoms is also same. But what is different then? The difference is there in their structure. So those are known as isomers. Now, isomers, they differ in both chemical and physical properties. Their chemical and physical properties are different. Why it is so? It is so because of the different arrangement of atoms. Now let us take some example and understand the isomers. So taking the example C5H12. Okay, this is what C5 means. It's pentane because this is CN, H2N plus 2. So it's pentane. Now see what all isomers can we draw. What is the meaning of isomer? So if I draw a straight carbon chain, there are 5 carbons. So I have put all the 5 carbons in a straight chain and then other valencies satisfy them with hydrogen. So you can see this is C5H12. This is C5H12. Same C5, 5 carbon atom and 12 hydrogen atom can also be drawn in this way. 1, 2, 3 and 4. 4 carbon atoms I have taken like this and one chain, branched one. I have taken 1 carbon like this. And all other valencies let us satisfy with hydrogen. There are 4 valencies for carbon. So 1, 2, 3, 4. Count the valencies and put hydrogen. Right, this is also C5. Let us count hydrogen. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Again, this is also C5H12. This is also C5H12. So you can see that the molecular formula is same, but their structures are different. So these are said to be the isomers of C5H12. Now let us talk about the different type of isomerism. So when we talk about different types of isomerism, according to the grade levels, there are different types of isomerism which are discussed. Being specific to grade 10, in grade 10 we talk about the structural isomers. So structure wise how isomers are there, and among them also there are many. As you grow up and study chemistry in detail, there will be many types, but over here we talk about the chain isomers, position isomers, functional isomers and ring chain isomers. Out of this, functional, position and chain are the 3 which are asked many a times. So one by one let us take an example and understand. First we'll talk about the chain isomers. So when we talk about the chain isomers in this, the isomers differ in the basic chain of the carbon atom. For example, when I take C5H12, in what all different way can you arrange the chain of carbon atom? Like you can put the 5 carbon chain like this, okay, or you can put 4 of them like this, and one you can put it over here. Okay, all other valencies will be satisfied with hydrogen as such. So this is a different compound. What is the name of the compound? What will be the name of the compound? The name of the compound will be pentane. Whereas when I do write the name of this compound, this basic chain is 4 carbon. So this is butane, and this is a group which is methyl group. It is, when I write CH3, it's a methyl group. Okay, so it will be 2-methyl butane. Okay. So all other valencies you satisfy with hydrogen. Let us count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So yes, this is also having a molecular formula of C5H12. Is any other way of putting the isomer, or can we form one more isomer? Chain isomer we are talking about? Yeah, it can be 1, 2, 3. What about taking the, okay, first let us finish with 4 carbon chain. Now tell me, if I put a methyl group over here, will this be an isomer? No, this will not be an isomer. This is the same thing, because this is also written as 2-methyl. This is also written as 2-methyl. So this will not be an isomer. But what you can do it over here is, you can take 3 carbon and place the other 2 carbons like this. So what it becomes? It becomes 2,2-dimethyl. Second position, 1, 2, 3. So it is 2, 2 dimethyl. You have put 2 methyl groups on the second carbon. So this is an isomer. All these types of isomers come under chain isomers. Coming to second type of isomerism which we are going to discuss is position isomerism. So position isomerism are the different isomers which you will get by changing the position of the functional group or double bond or triple bond, whatever is given. Let us take some example. For example, I take C5H11 and I put an OH group to this. Okay, so this is an OH group. So now the question comes, what all isomers can you make for this? So let us try the isomers. I will take a straight chain of carbon. Okay, I am going to put OH over here, and rest all positions let us satisfy with hydrogen. Let us count the number of hydrogen. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and this is the OH group which I have attached over here. So can you change the structure? Can you put this alcohol group at some other position and form a different structure with the same molecular formula? Yes, it can be done. What if I take a straight chain 1, 2, 3, 4, 5 and put an OH group as the terminal group? Okay, I am putting OH as the terminal group, and then you all other positions satisfied by hydrogen. So these are the position isomers. The name, IUPAC name also will be different. What will be the IUPAC name for this? This is 2 carbon. The numbering of carbon starts from the carbon which is near to the functional group. So this will be 1, this will be 2. This has OH group on the second carbon, whereas this has an OH group on the first carbon. What if I do it like this? And at this position we put an alcohol group. Yes, this is also one of the isomers. Putting alcohol group over here, will it make an isomer? No, because that will be similar to this. Again, putting over here will not make another isomer because it will be similar to the first one. So when you change the position of the functional group, or if double bond is present or triple bond is present, when you change the position of double bond and triple bond, then you get positional isomers. Now coming to functional isomers. What are functional isomers? So talking about functional isomers, we need to take an example where molecular formula is same, but the functional group differs. The functional group is different. So we can take the example of C3H6O. When I take this example, you can form a structure with 3 carbon, put a double bond O, okay, ketone group, you can put it a ketone group over here, 1, 2 and 3, 1, 2 and 3. This carbon, all the 4 valencies are satisfied. You can count 1, 2, 3, 4. So this is one of the structures which can be formed with the molecular formula C3H6O. Okay, this is a ketone group. So functional group is ketone group over here. Can you change it and try making something else out of it? Yes, let us do that. So when I take 3 carbon like this, what can we put an aldehyde group over here? CHO group. C double bond with O and H. It's an aldehyde group, right? So 1, 2, 3, 4 valencies are satisfied for this carbon. Over here I can put 2 more. Over here I can put 3. So see here, this is again C3, H is 6 and O is 1. So these are isomers of each other. And what type of isomerism do they show? They show functional isomerism. Okay, now coming to the ring chain isomers. So these are the isomers with the same molecular formula, but what is different then? The difference is that one of them will be a straight chain, another will be in the form of ring. So let's take the example. For this we can take example for C3H6. So this is CnH2n. That tells me that there is a double bond present in this. So one structure I can form 1, 2, 3 carbon, put a double bond over here, satisfy the other valencies with hydrogen to check whether the molecular formula is coming correct or not. So 1, 2, 3 and the 4th valency. 1, 2, 3 and the 4th valency. 1, 2, 3 and 4. For each carbon you have satisfied the 4 valencies. So count the hydrogen 1, 2, 3, 4, 5, 6. So this is C3H6. Now this is a chain, right? What else can you draw with C6 in your hand and C3 and H6 in your hand? You can make a structure like this, 3 carbons. Okay, you can put them in a structure like this. Okay, so let us satisfy with hydrogen and check whether this gives me C3H6 or not. So 1, 2, 3 and 4. 1, 2, 3 and 4. 1, 2, 3 and 4. So this is again C3H6. This is also C3H6. Okay, but they are different compounds. They are isomers. What is this? This is propene. 3 carbon pro and double bond propene. Whereas this is cyclo, because it's a closed ring. So cyclopropane. All are single bond. So cyclopropane and this is propene will be the isomers. What type of isomerism is this? This is known as ring chain isomerism.